So let's have a look at some more problems about maximum and minima. So we've got a business here and they want to grow some grass and they only have 25 linear meters of fencing wire. So they're going to plant the grass up against the side of a building to eliminate the need for fence one of the sides. So this is what our graph's going, our scenario is going to look like. And if you haven't got a diagram, draw one up. Sometimes problems come and they'll give you a diagram, but sometimes they won't. So just draw a quick one up. Remember, part of problem solving is drawing diagrams. So we've got our wall there, and remember the wall. We've got two sides are the same and one it's not because it's going to be rectangular. So that fencing there, the 2x and y would equal 25 because that would be the perimeter of the fencing we've got, and there's 25 meters of fencing, so that becomes 25. So take care against the wall because it's not 2y, it's just one lot of y, and that gives us our first point, which is to get one variable in terms of the other. And we should have taught this, what should be the dimensions of the enclosure? We want to find those dimensions. So again, we need to look at our area, which would be x times y, but can't derive that because x and y are different variables. So one variable in terms of the other. There's our area. We substitute y in. 25x minus 25 minus 2x, so x times that gives us the area of 25x minus 2x squared. Again, to get our maximum or minimum area, we derive it and set it equal to 0. So it's not a hard derivative, it's not a hard problem to solve for value for x. So we get x is equal to 6 1/4. When x is equal to 6 1/4, we get for y equal to 12 1/2. And we get our second derivative. Well, the second derivative of 25 minus 4x is just minus 4, which is less than 0, which makes it a maximum. Because it is. Second derivative is less than 0, it's concave down. So that must be the maximum value we get when x is equal to 6 1/4, y is equal to 12 1/2. There's our dimensions. This time we've got Lisa designing a garden bed, and it's consisting of a rectangle and a semicircle. So the perimeter of the garden bed is to be 20 meters. So the perimeter around the outside, 20 meters. So again, this time we want to find h in terms of r. So notice again we've got radius there. This would be 2r, height of the rectangle. So we need to find, well, the first part is to find h in terms of r. Again, one variable in terms of another. So the perimeter would be two lots of h, 2r, and then half of the circumference of the circle, which is pi times 2r, so half times pi times 2r. And we know the perimeter is going to be 20 meters, so we can sub that in for the perimeter. And we get 2h, 2r plus pi r, and it's all equal to 20, so we swap over, we take the 2r and pi r, subtract on both sides to get 2h by itself, divide by divide by 2 to give us h in terms of r. So that the area of the garden bed would be equal to that formula. So we know a rectangle would be h times 2r, and the area of the semicircle is a half times pi r squared. And then we can substitute h in. So it's just going to give us our function there in terms of r. So, which is what we want. We want one variable in that formula for the area. So the next section we can do, the next step is to find the maximum area. So the value of r that gives the maximum area. So we know we derive it. So we need that function all in terms of r. Derive it, set it equal to 0. So we get that and start to solve. So we get 4r plus pi r. So r would be equal, we can factorize r out, 4 over pi, 4 plus pi, which then we can divide by there to get 20 over 4 plus pi, which approximately equals 2.8 meters. So that's the approximate value of r. Show that it's a maximum, so we get our first derivative, we get minus 4 minus pi. Now remember when you're doing this, pi is a constant. Pi is not a variable. So don't differentiate with respect to pi or anything else, just treat it as a number. So because minus the number, it's less than 0, it's a maximum because the second derivative is negative. It's concave down. So therefore we can get our area by substituting the value of x, and we're just going back to that function that we had. We had the value of r as 2.8. We didn't bother to work out what h was, because we can just substitute it back, because we got a function for the area in terms of r. So sub it back in. We get that if we want to get it exactly, or if we're looking for an approximation, 28 meters squared. So there's our process in a couple of problems. What we need to do, keep going back to the last video with that table we had. What are the 4 steps? Get one variable in terms of the other, derive the function and set it equal to 0 to find the maximum and minimum problem, the maximum or minimum value, and making sure we're testing our maximum or minimum value.